Okay, so let's investigate the electric field lines further. So now we have combination of charges, not just one charge creating a field. And we're focusing on the electric field, okay? So those lines that they show here are the electric field lines. And remember what we learned so far, electric field originates from positive charge, terminates on a negative. So if you look at part A, um, it does just we said, right? It originates from positive charge, positive Q on the left side, and it's radially outward, and then it terminates in the negative Q. And you can see the arrow directions, those are the directions of the electric field. And also if you count, so if you just like make a circle around this Q and there as well, and then see how many electric field lines piercing through that circle on each, you'll find out that they're the same number. Okay, the reason is they have the same magnitude. So we understand also the number of lines are related to the magnitude of the charge, and the direction of the E field is related to the sign, the type of charge. Okay, and then here they're showing that if we choose this point, let's say the two charges were given in a problem, they're saying we have positive Q and a negative Q. They're putting on a kind of horizontal line, and they're saying if you kind of draw a vertical line from there, from the line they're connecting the charges, and find the E field at this point. Okay, so what we need to do is then just focus on that point and think about positive Q. The electric field is radially outward, so you draw this electric field vector, and then from that point for negative Q creates an electric field towards itself, right? Again, positive charge away from it, negative charge towards it. Okay, that's all I used, and I started my vectors from the point of interest, just an arbitrary point for now. And then these are one of them is the electric field due to positive Q, the other one is due to the negative Q. And how do we find a net force? Not force, net electric field? We do either parallelogram or tip to tail method, right? As we learned. So we can take this one on top of that and then go back and draw the line and put an arrow on top. That's your net E field. So the net field at that point is to the right. Okay, and you can do that in any point again. And if you look at the electric field lines, you can also say at this point, this is the electric field line, so it's going to be tangent to the line, and that's the net electric field. Okay, and here, for example, the net field is this way, and so forth. For part B, we know that the charge on the right side is negative Q. What about the charge on the left side? Okay, so if you count the number of lines, you will see that the left one has double the amount of lines. Remember that the number of lines are related to the magnitude. So if it is double, then this should be Q2, 2Q, because Q has half of the number of lines, okay? And how do we figure out the sign of that charge? Looking at the electric field direction, it is radially outward, it's away from it, so we know that this is a positive 2Q. Okay, so it's like a puzzle, and you're finding out the missing piece. Looking at the electric field lines, of course. In this case, yeah. So the right on part C, the right side we have a positive Q, and left one we don't know. Again, if you count the number of lines, then you can see how symmetric they are. That means they have the same number. So this should be left side should be also Q, right? And is it positive or negative? It should be positive. That's the reason they're not connected. If you realize this, they are just like diverging, right, from each other. It is because they are the same charges, and then the electric field lines never cross each other. Okay, so you can see on part A and B, they can originate from the positive and then terminate on the negative. But if the charges are not opposite charges, they are just going to terminate at infinity. Okay, and they're not gonna cross each other. So these are the main things that we learn. And one thing I want to ask you is that on this page in part A, B, and C, all of them, there's only one point. The electric field is 0 at that point. Can you figure that point out? Okay, again, remember, just because there's spacing between the lines, it doesn't necessarily mean that electric field is 0 at that point. Okay, so but there is a point among one A, B, and C cases, only one single point the electric field is 0, and nowhere else electric field is 0. Can you figure that point out?